Hi, everybody. My name is Miles Ward. I'm the global head of solutions for Google's cloud platform. And what that means is I help people adopt the cloud, move to the cloud. I have an incredible privilege to introduce a friend of mine that I did not help move to cloud. They did it all on their own. And as a result, they really know all of the wrinkles and the hard steps that it takes to figure this out. And the results that they've received are absolutely incredible. So I can't wait for Niels Pomerin, who is the Senior Engineering Manager for Nest, to explain to you how they've moved to cloud. Are you excited about that? Sounds good? Awesome. Thank you so much.
Perfect. Thank you, Miles. This is pretty amazing. You guys are comfortable? Perfect. Last time I've been this far in front of a movie theater was like the premiere of Titanic or something, but it's a long time ago. Thanks for coming. I'm Niels Pomerin, as Miles said. I'm leading SRE at Nest, and I'm very excited to share with you our story, how we migrated onto Google Cloud. Real quick poll. Who here has migrated to Google Cloud recently over the last couple of years? I see one hand. It's really hard to see. A couple of hands, perfect. Who here is planning on moving to Google Cloud? That's even more hands. So perfect. That's great. So let's see how this works. Next. Just to set the stage, I just wanted to share the numbers and the scale of the service that we're operating to support Nest cameras. Has anybody here, and I'm going to keep this casual, like does anybody here have a Nest camera at home? A lot of people. Very cool. Thank you, first of all. It's really massive, and we were facing a challenge really on two axes. Number one is just the sheer size and the scale. So we're operating on hundreds of thousands of cores. We're recording tens of petabytes of data, and the data just keeps coming at like hundreds of gigabits per second. So that's obviously number one, getting that amount of compute and data over into the cloud or into Google Cloud. The other one comes just with the service requirement and the customer promise that we're making. So as you know, as customers, we're recording 24/7, and we're doing so, and the customer expects 0 skips in their timeline, so they can go back to any particular event. The other one is that we make a customer promise that they at any given time can open the app and actually check in on their video footage, and all of that in millisecond latency. So that's what we had to move. Pretty big service, certainly the biggest service I've ever worked on. Let's go back a little bit. Where did we come from? So about 4 years ago, pretty much exactly 4 years ago, Dropcam was bought by Nest. And Dropcam really has been the foundation of what is known as Nest Cam today. And then 6 months prior to that, Google bought Nest. So that kind of brings up the obvious question, like, did they make you do this? Like, did they make you move on to Google Cloud? And I want to debunk that because it would actually like cut the talk in half because we talk about our decision process. So the short answer is no. We are, up until recently, we're an alphabet company, and we call them other bets. And as a bet, you really make your own decisions. So, and it's also fair to say, like, there's good parts of Nest that continue to run on AWS, and there's other bets that are not on GCP that are also either self-hosted or in other cloud providers. So the decision process that we're talking through is completely self-made. Okay, so where were we? About 4 years ago, Nest was already a pretty big place. We had thermostats, smoke detectors, we had cameras. Since then, we've added more cameras, more thermostats, security system, et cetera, et cetera. Today, I really want to focus on the camera side of the business. The camera in AWS was built, or the camera service was built with common AWS components such as EC2, S3, DynamoDB, and then for analytics, Redshift, and Kinesis. I like to use the analogy of a box of Legos. Each cloud provider has their own, kind of tiles, and some of them are very compatible. So if you compare like S3 to Google Cloud Storage, they fit very well together. But then there's other services such as DynamoDB that you have something like that in the Google Cloud box, but you actually need to adjust your build quite a bit to create the same customer experience. So that's kind of what I'm going to walk you through, how we found replacement technologies for all of these. The other thing I wanted to say real quick, as we were acquired, much smaller operations, we were operating on tens of gigabits of recording, which it was the equivalent of hundreds of years per day. Today, we record in the thousands of years every day of video. We were running on hundreds of servers, and they were still scaled fairly manually. They were provisioned automatically through Puppet and Cloud Init and so forth, but definitely less mature than we are today. But then, the Nest acquisition was a great opportunity, and it really supercharged the demands on our cloud infrastructure. So, number one, Nest already had a foothold in Europe, and we needed to follow suit. So very quickly, we had to move our operations into a global operation. The second one, Nest allowed customers on newer cameras to turn their sensors from 720 to 1080p. And with all the image recognition and so forth that we're doing, that actually means you need to operate on about like twice the amount of pixels. So, and last but not least, we have constantly, over the last 4 years, we have constantly improved our vision algorithms to actually send meaningful events to our customers. So that also caused a significant increase in just compute demand. So we were faced with the decision, what are we going to do? And let's talk through how we ended up deciding to go to Google Cloud. So without a doubt, probably for us, the biggest reason was the global nature of Google's network and its components. So for our service, all the video is obviously recorded in the cloud, but then the video that is live viewed is actually being reflected off the cloud. So as such, it's actually fairly easy to understand, like the closer you get that compute to the customer, the better the experience is going to be, the lower the latencies are going to be. So as we enter new markets, it's really important for us to have a presence as close as possible. So Google Cloud helps there, right? And we'll look into that in a second. So building a multi-region story in cloud, whether you do it for just proximity like us, or regulatory reasons, or quote unquote just to achieve resiliency, it just seems very easy, or from experience, it's very easy to do it with Google Cloud. So that was one. The other one was savings. So if you run a business, you're obviously worried about operating costs, you're worried about margins. One cost that we're tracking is the cost or the service cost of operating a camera. This is real numbers without the actual values, but this is how we have seen the cost of operating a camera decline over time. Now, I do want to say it's highly dependent on your use case. So in our use case, we actually stripped everything apart. Enterprise agreements, RIs, just like stripped that apart, looked at street pricing, compared that to Google Cloud pricing. And with that alone, we've seen a 20% decrease in operating cost. Now, in real numbers, that means tens of millions of dollars for us. And that's just in 1 year. Very, very massive. And obviously, our finance team is excited about it, but we are too, because what it actually allows us to do is fund new features. So we are building additional features, and some of the features that you see on your cameras today have been funded through those kind of cost down efforts that we continue to drive. So Google Cloud really helped us there as well. So let's take a look at the migration approach. So in a nutshell, this is what it looks like. And I really was hoping this is like a smaller room so I can show up here, but I have a laser pointer. Cameras stream into the cloud. From there, video is recorded into S3, and video metadata, along with any sort of event that we have detected, goes into DynamoDB. Great. And then the client, whether you use your browser or your phone, is rendezvous on the same server, and you can consume the stream or watch recorded video. Now, when we started off, we sat down with the Google Cloud folks, and we were like, hey, couldn't we just move that S3 thing down into Google Cloud Storage? It's a great idea, but the way all public cloud pricing models work is all your inbound bandwidth is free, but outbound isn't. So, it would have been really cost prohibitive to do any sort of hairpin turn in AWS just to store it into GCP. So what we had to do instead is like really build up the entire stack in Google Cloud and build the necessary abstractions to, for a server that is in Google Cloud to know to talk to Google Cloud Storage and to Spanner, respectively, as a replacement for S3 and DynamoDB. So that took a while, but it was, it was the way to go. And then the actual migration became trivial. So we updated the database record, said, you now belong to Google Cloud, and we could do this one camera at a time, which is really important. You now belong to Google Cloud. We sent the camera a disconnect signal. The camera dials back in, connects to Google Cloud, and starts recording over there. Easy, we're done. This works extremely well, by the way, for new cameras. But what about the cameras that have been recording and have data recorded, assume they're on a 10-day recording plan? So what we wanted to avoid is a big copy job, because ultimately it would have still been egress charges. So, and also if you imagine that many of you are users, not all the video you have ever recorded, you actually look at. It's a small fraction of the video that we ever actually play back. So, and on top of that, the data is actually self-expiring. So after 10 days, we have a customer promise that we're going to delete the data. So what we build is a technology called scatter gathering. So if a client requests video, now connected to Google Cloud, that is still stored in AWS, we just pull that in automatically across clouds, stitch it back together, and present it through the API as if it would be all in Google Cloud. Now, it's very specific to our use case, but what's interesting here is you can do this with any application. Like even if you have S3 log processing and the data is expiring over there, you can easily use public cloud APIs securely over the internet. Bringing back the Lego analogy, there's no reason why you can't intermingle those different services. So it was kind of a breakthrough moment for us to really keep migration costs under control. All right. Next, I want to talk about the how we build a global architecture. So to do that, I want to talk through real quick how a camera first connects. When you first power it up, it goes through this routing lookup layer where it, backed by a load balancer, which in turn is backed by compute engine instances. And we do a quick lookup, figuring out where this camera belongs, and then actually connect this camera straight to the owning server of that camera. Now, very quickly, you can add a couple of regions, right? And now really try to look at both ends of this, right? Whether it's the load balancer on the left side, with a couple of API calls or clicks, you can add compute engines from any region really to that load balancer. And if you look at it from the right side as well, whether it's the global Spanner storage or or global or within the geographic region, a Google Cloud Storage bucket, all these things and other services that I'm not showing, such as PubSub, just are global in nature, making it very easy to build a global infrastructure. The other thing that's important here, and it's not shown, is it's really the same VPC network. It's the same firewalls. It's the same public APIs that we've called, and the same public API endpoints to launch these instances. It's really just a matter of specifying the launch region of where you launch your instance. And last but not least, all of them are connected through Google's fast backbone. So even if you have cross-region traffic, you don't have to deal with VPC peering or anything like it. It just works. Next, we can just add an entire continent, right? So going into Europe, for example, going into Asia next. Now it's very cookie cutter to go into new markets and new regions. And SRE or operations is now no longer in the way of the business to enter new markets, which is really a great enabler. Yeah, that's how we build a global architecture. So next, I want to talk. There's like 3 takeaways I think that I want to talk about. And the first one is like focus on reusable tools. So doing a migration like this is like a huge investment. So in our case, we've written thousands of lines of codes, and at every step and every turn, we've asked ourselves like, is this a one-time deal or is this something we could actually like reuse in the future? So I want to show you. Remember Scatter Gathering? How we brought things from AWS like on demand over. So imagine like whether it's like a future feature or something we do automatic as part of like a DR strategy or so. But like, let's imagine we're moving a camera from the US to Europe. Like, why wouldn't we want to like use Scatter Gathering that we've now once built to pull in data on demand from other regions if we had to, and then stitch it together and present it back? Imagine a camera, or an owner moving, taking the camera with it. You can take it as far as like in the future sensing of where that camera is best connected. So again, it's just one example of reusability. It's something that we really, really focus on during this migration. My next favorite topic is to think outside of the ops box. This is probably the most important thing that I learned during this migration. So I run SRE, and I was tasked with getting the service over to Google Cloud. But my lesson here is like whether you're SRE, PE, DevOps, NetOps, make it known within your organization that this is really a cross-functional exercise. And if you do it well and you really focus on the customer, you can really build a seamless experience, or make the migration extremely seamless, and you actually end up, or possibly, and I'll show that, in a better place than you were before. So I want to show 2 quick examples. Number one is for the live viewing case. So if you do this poorly, you can easily get to a point where, like, okay, we migrate the camera. First of all, we try to avoid migrating a camera while it's actively being viewed. But let's assume for a second you migrate a camera while it's actively being viewed, you move it over, send it a disconnect signal, it comes back in. If a customer is viewing this camera feed, it turns black, customer has to exit the app, go back in, and so forth. It's frustrating. So we work very closely with the apps developers to say like, hey, if we send you a signal that we just changed regions, can you just like reestablish show a spinner for a second? And that's effectively what we did. But it actually now improves the resiliency in our communication and signaling between apps and cloud. So it's one example. The other one is around the recording model. So the cameras, and this is something where we worked with the embedded team. Again, we own end-to-end of the communication. So we worked with the embedded team, and we use something we call backfill. So the camera in itself has a little 2-minute buffer. So when we send it the disconnect signal to come back into Google Cloud, it's a 5 seconds. On the other side, in Google Cloud, the camera will negotiate with the service to say like, hey, where did you left off recording over in AWS or anywhere else for that matter? And we are trying, and then we're negotiating and stitching the timeline back together. So as a result, if you come back later that day and your camera had been migrated, you absolutely see no seams on your timeline, which is pretty neat. So again, it took a lot of effort to get there, but it's like we were that concerned about the customer experience during this migration. And then the other thing is like re-architecting, and do it often. If I would have waited, or we would have waited for Google Cloud to provide us with a replica of what we had in Amazon, we would have never moved, right? So you do need to adapt. And if you look at the marketing material, very often what I found is like it scratches the surface of what the actual performance characteristics are of their services. And even if you look at things like S3 and GCS, they're ever so subtly different. I encourage, as you go down this road, I encourage you to stay, very nimble and really embrace that you need to make changes a lot. So here's a very simple example that you can wrap your head around. So the average recording node in AWS looked something like that. So we're using C3 instance types, and we really like them because they come for free with these awesome ephemeral drives, super high IOPS, 2 times 80 gig. We strapped them together, and we use them both to spool video before we flush it out to S3, but we also use it to keep a cache of recent video, so we don't actually have to retrieve it from S3 every time a customer requests something. Now, we're like, okay, sweet, we can build the same thing over in Compute Engine. So we're like, oh, let's take an N1 standard 8, comes with 30 gig of RAMs, really very similar performance characteristics. And we plugged a hard drive in, PD, 180 gigs, 160 gigs, and we're like, oh, this is gonna be great. It worked phenomenally well in QA, but once we actually put it in, load under it, put it in, or load tested it, it turns out, and it's not the fault of PD, we just it doesn't match the I/O capacity of an ephemeral SSD drive. So we're like, okay, that doesn't work. So next, Google has a similar, and this is why I'm saying both of them check the check marks. They have ephemeral drives. Google has a drive that's 375 gigs, local SSD. It's as volatile, it's as fast. The problem is though, it's too big. It's the smallest denominator that you can attach in local SSD. The problem is, and for most customers, it's not a problem because they actually attach 10 or so of them to run big Cassandra nodes. But in our case, if you operate thousands of these servers, it would have just been a giant waste. So we kind of ruled that out as well. And then we started thinking, let's take a look at the 180 gigs or 160 gigs and see what we actually use them for. So we added instrumentation around your cache hit rates, your cache miss rates, and so forth. And it turns out we actually didn't need all this storage. So we ended up with a machine, and this was all in a matter of a week or so. So again, staying very, very nimble. We ended up with a machine that was an N1 High Mem 8. That's how it's called. So it just comes with more memory, and we carved out a 25 gigabyte hard drive. And it's as volatile as a local SSD. It has even better IOPS performance. And in the process, we saved a bunch of money as well because we didn't have to attach all these additional drives. So it's that kind of thing where you really, once the rubber hits the road, you really need to make adjustments and embrace that and be open to that. So, great. So, takeaways. This kind of ties back into the hard drive story. Don't be afraid to experiment. My number one advice is invest in good instrumentation. You want to set the baseline of what the customer is experiencing in your old cloud provider. And then you really want to say with confidence whether you're moving the needle in the right direction or in the wrong direction. The other thing I feel fairly strongly about is forklifts don't work. You don't want to come in on a Monday and change DNS of your entire service. I really try to move either one customer at a time or if data, in our case it didn't work due to data constraints, but if you can, one service at a time, have a fail-back strategy and so forth. We did that more than once, where we, in the early phases, where we moved a couple of cameras over and then we moved them back, in internal cameras. And then, as I said before, it's like hitting 6 right numbers in the lottery. You're not going to pick the right infrastructure on the get-go. So really, I encourage you to stay nimble and actually embrace that fact to make changes often and see if you move the needle in one way or the other. That's one. The other one is focus on reusability. So I said before, it's not an SRE, PE, DevOps problem alone. Really try to focus on the customer. And you do have an opportunity, just as I showed you, to actually come out with a service and a platform that is better and more stable than it was before you actually went down on this journey to migrate to cloud or to Google Cloud. And last but not least, save money and have fun with it. It's something that we do. It's in our DNA to constantly create additional headroom for features, and we've just scratched the surface on it. Sustained use discounts you kind of get for free, but then Google has great knobs to really drive your operational costs down. So we are looking very heavily into auto-scaling, and we're very excited about preemptible VMs in particular for some of our workloads to reduce costs even further.